Hello guys, welcome to my video series tutorial to talk about semantic kernel agent orchestration. So far we have seen three types of orchestration: sequential, group, and concurrent pattern. So in this video I'm going to focus on transform concept. There are two types of transform concept present in agent orchestration, one for input and another one for result. Input transform. So the purpose of this one prepares data for processing. That means based on your input, that means your prompt, you can convert this input to based on your project or agent needed. The source input, you can convert it. That one for input transform. Another one for result transform. This mainly used for convert processing result for output. So once the agent send the response, you can process it, how the final output should present to the user or developer, how you want to response, the final response that you can decide with this result transform. So the first part we'll see this input transform. Second part we'll see the result transform concept. So to implement this input transform, I used our last example, concurrent pattern only. I'm going to use the same action and romantic classical fan agents, and the input same. Suggest a good movie to watch this weekend in Tamil. The first session, this input transform, what I'm going to do, I'm taking this input I'm going to rewrite to be clear, grammatically correct, and ready to use for the AI model. So that's the concept we are going to implement. For that, I have already written the prompt input transform class. So this class has a constructor. We have to pass a kernel object, and this class has a one function, transform async function. This function we have to pass the input. So the user input we pass to here, and here I define my system message and user message. So the system message written, you are a prompt engineer, rewrite user prompt to be clear, grammatically correct, and ready for an AI model to understand. And the user input I added here. So once the string is ready, we have to convert this string to the kernel function. So we cannot simply pass this string directly to the kernel. So we have to convert this string as a kernel function. To convert to the kernel function, I have used kernel function factory. This is a static class. Here I use the function create from prompt. I pass our string here, this chat prompt. Our function is ready. And using this invoke async function, I pass our kernel function and get the result. And using this get value function, we get the output from the model that is called transformer input. In case if it is null, then I assign the same input just for fallback concept. Most of the time it won't be null, but just for fallback I added this one, and here we return the rewrite prompt. So this function I'm going to call in our concurrent pattern example. So go to our class program.cs file here, this one. So how to call this function? So in the concurrent orchestration, we have callback called input transform. This is a callback function. So here we have to create our callback function. So create method, and this method get invoked. So once we pass the input, before invoke the agent, this callback get triggered. So input transform callback get triggered. In this function, we are going to call our prompt input transform. So here, first I'll print the what input we receive from the user. So right line. So we define like user input. So whatever input that we just print, and here simulate some transform logic, and I'm creating the object for our prompt input transform. and create the variable new. So here we have to pass a kernel. For that I just create the one more kernel object, not Azure, just this local model enough for this one. So I use llama and kernel, pass it here. So the next we have to call the transform function. So where rewrite prompt. So this is our rewrite prompt or rewrite input equal to prompt input stream dot transformer async function. We have to call this. This is asynchronous function. We have to convert our input transform function to the async function. So here I add a async, and here we'll add a wait, and we pass the input. So the input and cancellation token we have to pass. So once we get the response, we just print the response output also, right line. This one called transformer input. Okay, so this is we just written new list of chat message and new chat message content. So author is user, our rewrite prompt, just written it. And here you can notice the return value is a IEnumerable. That means a list of chat message contents. We have to return it. If you want, you can add more message also. So not only this, if you want to add some other information, you can just add user, and you can add your prompt. So for this sample is not required. I just keep the only rewrite prompt, and this prompt we return to the agent and agent process it. We quickly run this application and see the output of this one. So this is our prompt, suggest a good movie to watch this weekend in Tamil. And before passing this prompt to the agent, first this callback get triggered. In this callback, we used our prompt input transform. So this user prompt going to rewrite using this prompt input transformer class, and rewritten prompt we send back to the agent. So we run this application and see the output. Started. First user input, such as a good movie to watch this weekend in Tamil. This is our prompt, and we see this input transformer, how it changed. So here is a rewritten prompt, recommended a popular movie to watch this weekend. So this is our rewritten prompt, and here the changes has been made, and here we get the result. So classical one, and this one I think is an action movie, and another one is a comedy one. Fine. So this is a simple example how to use input transform callback, and whatever changes we want to do before send prompt to the agent, we can do it here. This is a simple example. This is a string input. If you want to, you can make a structure input also. That also is possible. Fine. The next topic, we move to our second concept, result transform. A result transform purpose convert processing result for output. So once agent responds, you can convert it to your formatted output. Like if you want to custom class, you can do that also possible. So what I'm going to do, once the agent responds to this movie information, I converted this information to the movie recommendation class. So I split properly, like movie name, title, released year 1986. So something like this. So in that class, I'm going to add some property. Once agent responds, this response I pass to the LLM, and the LLM convert this input to the our custom class. So this I have already discussed in one of our semantic kernel application, JSON formatted output. The same concept I'm going to use it here. So write a simple class called movie recommendation. So here I have created class movie recommendation. I added some property like title, description, release year, something like that. So overwrite on function to string and just return the all the property information. This is fine. Go back to our program.cs file. To implement this feature, the first of the concurrent orchestration, we have to set what is our input, what is our output. So that we have to specify. So if you see this one, first argument we had as an input. So the input is a string only. So there is no changes. We not used any customized class or something like that. It's a plain string. So argument is clear. First input is a string. Second argument is the output. The output is, for this sample, we need movie recommendation. Plus, we have to collect all the output from all the agents. So here we used three agents. So three agents send three response. From that response, we have to fill this movie recommendation. So that means it's not a single object, it's a collection of object. So we have to use a list. So here specify is a list and the custom class, it's a movie recommendation. So we changed concurrent orchestration input and output. Once it's done, we have to implement the result transform. Again, this is a callback. So here we have to implement the function. So if you implement the function here, you can see the value task changes a list of movie recommendation. So this is our output, and here we get the input. All the agent input come in this parameter list of chat message content. Define the variable movie recommendation and recommendation movie. This is return value. Okay. The next step, we have to take the input from the result list and we pass the list information to the LLM model. LLM model convert to the movie recommendation class. So for each where chat message in result and each result we have to pass to the LLM model. So each input we have to pass a LLM model. The LLM model we have to convert to the movie recommendation class. To implement this LLM concept, we no need to write the from scratch. Instead, Semantic kernel provide the class called structured output transform. We have to use that class and convert our output to our custom class. So here I write the structured output transform and we have to specify our custom class movie recommendation and declare one variable structured output transform and we check the parameters. First argument is a chat completion service and second argument prompt execution settings. Chat completion service we have to get from the kernel object and prompts execution setting we have to set the response format, what type of output we need. So for this first argument we need the kernel object. So here I define the kernel and variable kernel model I change to Azure because we need to connect the OpenAI model. So Azure. So here we pass first argument kernel dot get required service I chat completion service we need and second argument prompt execution settings. So new OpenAI prompt execution settings. In these settings, the response format we have to set. The response format we need type of movie recommendation. So that's it. So inside for each, we define variable movie and here we call the structure output dot transformer async. So here we have to pass the chat message content. Before that, this is a async function. So we have to convert this function as async function here, async and wait. First argument, chat message content. The chat message content was as chat message here, chat message, and second argument we have to pass cancellation token. So once we get the response, we add into this list recommendation. So recommendations dot add movie. That's it. So far all is good. Check this line number 49. 49 written as a list of movie recommendation, and in the movie recommendation using the for each we read one by one, and here I change to agent dot toString. ToString contains all the property information, title, description and everything. So we start the application and see the output. So start. Up to here our input process only. Just waiting for the movie recommendation. Yeah. So here we get the output. So you notice title, description, language. This is first one, and this is the second one, and this is the third one. So previously we see the complete text information. Now the text information converted to our custom class. In the custom class, we just print this information. So now it's more readable. So this is a simple example how to implement a transform concept in agent orchestration.